In the last video, we discussed what sets are. In today's video, we will discuss how sets are represented. There are two different types of representation of sets. First is known as the roster form or the tabular form, in which all the elements of the sets are written within brackets separated by commas. So for example, the set of elements taken from the set of natural numbers, which is less than 6, can be written as 1, 2, 3, 4, 5. Or the set of elements present in the word apple can be written as A-P-L-E. One thing to note is in the second example where we use the word apple, P repeats itself multiple times. However, when we're writing the elements in the set, we only write P once. So if an element repeats itself multiple times, we have to write the element only once in case we're presenting the set in roster form. However, the roster form is not used if a set contains infinite number of elements. In that case, the second method of representation of sets is used, which is known as the property method or the set builder form. In set builder form, we do not list the elements of the set. Instead, we list the properties which the elements satisfies. So we know that a set is a well-defined collection of elements. The definition or the property which all the elements satisfies, that property is written in the set builder form. The general form of representation of a set in set builder form is X such that X has properties P, where we write all the properties X satisfies. So this can be better understood using an example. Say for example, we take the set of all the even numbers, which is less than 12. So in roster form, that set can be written as 2, 4, 6, 8, 10. These are the set of all even natural numbers, which is less than 12. In the set builder form, we have to use the property natural numbers less than 12. That is the property or the definition of all the elements present in this set. Now, the way to write that is, now I will explain one by one what I have written here. So the first element we write here, that is the final form of the element which we will write in the set. Here we have denoted x by a second variable n, and we have written x is equals to 2n, after which we have put in different restrictions and we have written the properties of n. We have written that n should be a member of the set of natural numbers and the value of n should be less than equal to 5. From these two properties, we can easily find the values of n. Since n comes from the set of natural numbers, the values of n should be 1, 2, 3, 4, and 5. Till 5, because the upper limit or the restriction of n is that n should be less than equals to 5. Now, after getting the values of n, we plug in these values in this equation. From that, we get the values of x. Putting n equals to 1, we get x equals to 2. Putting n equals to 2, we get x equals to 4. Putting n equals to 3, we get x equals to 6, and so on. After getting the values of x, since the final form of the element is also x, so from this we can get the set in the roster form. The first element will be 2, second element will be 4, third element 6, fourth element 8, and fifth element is 10, which gives us the set of all the even numbers less than 12. However, writing a set in the set builder form is not a unique representation. A same set can have different representations of itself in the set builder form. For example, the same set can be written as such. Here, instead of describing x in terms of a second variable, we have written the final element of the set to be 2x. That means from these two given properties of x, we will first get the values of x, and then we will plug in those values in this final form of the element. So these two properties are x belongs to natural numbers, so the values of x should be 1, 2, 3, 4, 5, and so on, and the limit or the restriction of x is the value of x should be less than equals to 5. From this we get the values of x as 1, 2, 3, 4, 5. If we plug in those values here, we get the value of x as, when putting x equals to 1, we get 2x equals to 2. When putting x equals to 2, we get 2x equals to 4. When putting x equals to 3, we get 2x equals to 6, and so on. Since these are the final values of the elements of the set, so if we write this in roster form, we get the set 2, 4, 6, 8, 10. So you can see that the set builder form is not unique. Here the set builder form is different, here the set builder form is different. However, if we write the elements of the set, we can see that the roster form for both the sets is the same. The only challenging part of writing a set in the set builder form is to understand the pattern or the definition in which the elements are written inside the set. So for example, let us take a set P equals to 1 by 2, 2 by 5, 3 by 10, 4 by 17, 5 by 26. Now this is a set which consists of fractions in which the numerators are natural numbers starting from 1 up till 5, but the denominators are random numbers. We have to first understand the pattern in which the denominators are written. If you can see that in each of the fractions, the denominators are basically 1 more than the whole square of the numerator. So for example, in the first case, the numerator is 1 and the denominator can be written as 1 whole square plus 1. In the second case, where the numerator is 2, the denominator can be written as 2 whole square plus 1. In the third case also, the denominator can be written as 3 whole square plus 1. So in the set builder form, the same set can be written as b equals to x such that x equals to n by n square plus 1, where n belongs to natural numbers and the value of n is less than equals to 5. From these two properties, we get the values of n. Since n is a natural number less than equals to 5, so the values of n are 1, 2, 3, 4, and 5. We then plug in the values of n in this equation. From that, we get the values of x. So putting n equals to 1, we get 1 by 1 square plus 1, which is 1 by 2. Putting x equals to 2, we get 2 by 2 square plus 1, which is 2 by 5, and so on. So if after getting all the values of x, if you write the set in the roster form, you will get this set. A similar example can also be taken for this set, where c equals to 1 comma minus 1. This is the roster form of a set which consists of two elements, 1 and minus 1. If we write this set in the set builder form, the set can be written in multiple ways. For example, the set can be written as x such that x square equals to 1, x belongs to z. This means that the elements of this set must satisfy the equation x square equals to 1, where the values of x are to be taken from the set of integers. Now, solving the equation x square equals to 1, we get the values of x equals to plus 1 and minus 1. Since the final value of the set is also x, so the roster form of this set is 1 comma minus 1. However, this is not the unique representation of this set. You can also have this set written in multiple forms.